Hey gang, today we're going to be looking at 90-degree rotations. So yesterday we talked about 180-degree rotations and how that's a half of a turn. A 90-degree rotation is a quarter of a turn. So we won't be rotating over two quadrants, we'll only really be rotating over one quadrant. And there's some fancy rules that go around along with these that it would be really important to memorize so that you can do these pretty quickly. So to rotate a figure 90 degrees, you're going to switch the x and y for each coordinate and apply the signs of the quadrant it will turn into. I like to say 90 degrees clockwise, switch, change y. So you're going to switch the x and y, change the sign of the new y. 90 degrees counter, switch, change x. So you're going to switch the x and y, change the new sign, change the sign of the new x. All right, so let's take a look at what this looks like. So here we're going to start by graphing SCI. S is 1, 1, which is right 1, up 1. C is 7, 1, so that's right 7, up 1. And I is 4, 6, so that's right 4, and up 6. Right there. So we have what looks like an isosceles or equilateral triangle. Isosceles is when two sides are the same, equilateral is when all three are the same. And we want to rotate it 90 degrees clockwise. Switch, change y. So if I take S, it's going to become S prime. Switch them, it stays 1, 1. I change the sign of the new y, so it's 1, negative 1. C prime is going to become 1, 7, changing the sign of the new y, 1, negative 7. And I prime, if I switch them, I get 6, 4. Changing the sign of the new y, I get 6, negative 4. So that will rotate it 90 degrees clockwise. Now remember, clockwise is the direction of a clock. So if we're rotating around a clock, we go in this direction. That would be considered clockwise. Where this direction is considered counterclockwise. But by knowing the rule, it's going to happen for us naturally. So S prime is 1, negative 1, so we go right 1, down 1. C prime is 1, negative 7, so we go right 1, down 7. And I prime is 6, 4, so we go right 6 and down 4. And you can see that the triangle has rotated 90 degrees clockwise around the origin. And we already have C prime, so we don't need to rewrite it. All right, let's take a look at example number 2. So in this case, again, we're going to rotate 90 degrees counterclockwise. So we start with M, 3, negative 2. So we go right 3 and down 2. A is 1, negative 4. So we go right 1 and down 4. R is 3, negative 8. So that's right 3 and down 8. And K is 5, negative 4. So that's right 5 and down 4. So mark is this kite-looking figure. And we're going to rotate that 90 degrees counterclockwise. So we switch, change X. Okay, so M prime, if I switch 3 and negative 2, becomes negative 2 and 3. Change the sign of the new X, it's 2, 3. A prime, if I switch 1 and negative 4, becomes negative 4, 1. Change the sign of the X, it's 4, 1. R, if I switch 3 and negative 8, is negative 8, 3. Change the sign of the new X, it's 8, 3. And K, if I switch 5 and negative 4, I get negative 4, 5. Change the sign of the new X, it's 4, 5. So now, because I'm rotating counterclockwise, I would expect it to come up into this quadrant, and we'll see that by our new coordinates, that's what happens. So right 2 up 3 brings M prime here. Right 4 up 1 brings A prime here. Right 8 up 3 brings R prime here. And right 4 and up 5 brings K prime here. So each of the points were rotated 90 degrees around the origin to get the new coordinate. And again, you don't have to draw this, I'm just showing it to you. All right, so again, try to remember those rules. It'll be really, really helpful. 90 degrees clockwise, switch, change Y. 90 degrees counterclockwise, switch, change X. So try number 3 through 5 on your own, and keep in mind that a 270 degree clockwise is the same as a 90 degree counterclockwise rotation, and 270 degrees counterclockwise is the same as 90 degrees clockwise. Okay, so we're back with another algebraic problem dealing with rotations, which means that the shapes are going to be congruent. So if we take a look at this one, we have the area of a triangle is given as 18 less than 7/4 of a number. So we have a triangle, and we know that its area is 18 less than 7/4. Quarters implies dividing by 4, so it's 7/4 x minus 18. That triangle is rotated 90 degrees counterclockwise. So it's going to look something like this when I rotate it 90 degrees counterclockwise. But the two will still be exactly the same size. And that area is 14 more than 3/4 of a number. 14 more than 3/4 of a number is 3/4 x plus 14. And we know that their areas are equivalent because they're congruent shapes, since all that was done was a rotation. So we're going to set them equal to each other. So we have 7/4 x minus 18 equals 3/4 x plus 14. Subtract 3/4 from both sides. Cancels out, and we get 7 minus 3 is 4/4 x minus 18 equals 14. So that's just one x. So x minus 18 equals 14. Add 18 to both sides. We get x equals 32. Because 4 plus 8 is 12, carrying the 1, we get 32. So now we have x, we can plug that in, find the area, and prove that those two are the same. So we have 7/4 of 32 minus the 18. 32 divided by 4 is 8, times 7 is 56. And 56 minus 18, well, I can't do 6 minus 8, so I borrow. So it's 16 minus 8, which is 8, and 4 minus 1 is 38. So it's going to be 38. And if I try it in the other one, I should get the same answer. 32 divided by 4 is 8, times 3 is 24. And just as expected, 24 plus 14 is also 38. So the area of both the triangles is 38 units squared. All right, so now we've done all of the types of transformations that create a congruent shape. You're going to do some practice doing your exit tickets before moving on to today's homework.